as promised, we need to finish this chart that we made yesterday. So let's say that you're given a cube, like an x cube problem. This is a cubic problem. Its graph almost looks like a kind of weird looking S. And I'll show you on the graph so you can see. Let me clear out what I have in my calculator. This is what a cubic graph looks like. So it kind of goes and it takes a little turn. That's a cubic graph. Oh. Say the shadows on that just got really weird. This is a function because it does pass the vertical line test. Because it goes left and right forever, the domain is all real numbers. And because it goes up and down forever, the range is also all real numbers. The inverse of this graph is a cube root graph. And a cube root graph, let me show you on here. Looks like that. So it goes like that. Kind of takes a weird little turn there in the middle. The inverse is usually, I'm going to write yes, and I'll write usually, a function. For all things you see in my class, it's going to be a function, okay? The nice thing, if you remember, domain and range are always x and y, and they just switch these properties. So x gets y's values, so all real numbers, and y gets x's values, all real numbers. Last one, cubic graphs, or cube root graphs. They look like this. We actually just talked about one. Typically, yes, I'm going to write usually, they are a function, unless this middle part kind of overlaps funny. Because they go left and right forever, the domain is all real numbers, and the range is all real numbers. Their inverse is a cubic function, and they will look just like they did in the step above. These will be functions because they'll pass a vertical line test, and x and y switch these two values over here. So the domain is x, the range is y still, but x gets the old range and y gets the old domain. It just so happens that they are the same. So that's going to be important for us to remember going into today's lesson. Let's move on.